Welcome to Similar Triangles Day 1, or since this is a Star Wars unit, the Phantom Menace. Today we'll be reviewing the notes, practicing some more, and as Yoda might say, learn about ratios you will today. We're going to start by doing our warm-up. You should do the warm-up before you check the answers here. You can skip problems 3 and 4 because I will be skipping them as well. Number 1, we're just solving an equation. 2x plus 5 equals 20 minus 3x. Adding 3x to both sides gives you 5x plus 5 equals 20. Subtract 5 and 5x equals 15. Then divide by 5 and x equals 3. Number 2, we're going to use the law of detachment to make a valid conclusion. If today is Saturday, then Sarah will play soccer. Today is Saturday. What can we conclude? We can conclude that Sarah will play soccer. Very good. As I said, we're going to skip 3 and 4 here. Number 5, we're going to use the transitive property to complete this statement. If E equals F and F equals G, then, that's right, E equals G. Okay. Now we're going to talk about ratios, proportions, and geometric means. All right, a ratio can be written in several different ways. It can be written as A to B, or A over B, or A colon B. But we always want to reduce it and put it in the lowest possible terms. Number 1, we want to simplify the ratio 64 meters to 6 meters. So since 64 and 6 are both divisible by 2, we reduce that ratio to 32 meters to 3 meters. Don't change the order. It's the bigger numbers first. Keep it that way. Number 2, the ratio is 5 feet to 20 inches. An important thing is to make sure that you're always in that you're reducing everything. So 5 feet to 20 inches, they're both divisible by 5. That would give us a ratio of 1 foot to 4 inches. Number 3, we've got 24 yards to 3 yards. So they're both divisible by 3, and that becomes 8 yards to 1 yard. And finally, 150 centimeters to 6 meters. Again, we're going to reduce that, and we'll end up with 25 centimeters to 1 meter would be our ratio. Ratios don't always have to be two things. If there's more than two, we call it an extended ratio. So here we're saying the measures of the angles in triangle CDE are in the extended ratio of 1 to 2 to 3. Find the measures of the angles. Since we know that ratio is reduced, we need to now, instead of reducing it, we need to expand it and figure out what those numbers originally were. We don't know what we reduced them by, so we'll say it was a variable. We'll use x in this case. And we know the angles in the triangle add up to, I'm hoping you all said 180. All right. So the way we would set this up, since it's 1 to 2 to 3, would be 1x plus 2x plus 3x equals 180. Combine those, we get 6x equals 180. And if we divide, we get x equals 30. Then what it tells us to do is find the measures of the angles, not what we reduced the ratio by. So if we then plug those into 1x, 2x, and 3x, we'll get angle measurements of 30 degrees, 60 degrees, and 90 degrees. Number 6, the perimeter of a room is 48 feet, and the ratio of its length to its width is 7 to 5. Find the length and width of the room. One thing we forgot to mention here, and if you look around whatever room you're in, hopefully it's a rectangle, but that's what we're dealing with, a rectangle. So hopefully we remember the formula for perimeter of a rectangle is perimeter equals 2 times the length plus 2 times the width. So what we're going to do is, we know that, again, this is a reduced ratio. So our length is going to be 7x and our width is going to be 5x. So plugging that in, we know the perimeter is 48, and that's going to be equal to 2 times the length, which we said is 7x, plus 2 times the width, which is 5x, which gives us 48 equals 14x plus 10x. Combining like terms, 48 equals 24x, and if we divide by 24, x equals 2. Plugging that in, since we know x equals 2, we can just plug these in. We know our length is 7x. So 7 times 2 would give us 14 feet, and the width was 5x, and x is 2, so that would give us 10 feet. Make sure you have units in your answer if there were units in your problem. Number 7 is just like number 5, so I'd like you to try that on your own and we'll check it in class. Next are proportions. Proportions are ratios set equal to each other. This should be something that you've done in Algebra 1, but we're going to review it real quick. To solve a proportion, you cross multiply and then solve for the variable. So here we have 5 over 10 equals x over 16. You don't need to reduce before you do this. Just go ahead and cross multiply. So cross multiplying will give you 10 times x is 10x equals 5 times 16. Well, 5 times 16 is 80. And then if we divide by 10, we'll see that x equals 8. Over here on number 9, we have 1 over y plus 1 equals 2 over 3y. You're going to do the same thing here. You're going to have 1 times 3y is going to equal 2 times y plus 1. Be careful here because we have to distribute this 2. So 1 times 3y is 3y, and 2 times y plus 1 will equal 2y plus 2. We then subtract 2y from both sides and get y equals 2. There are several more on this page that we would like you, or a couple more on this page that we would like you to try. So go ahead and try these and they will be checked in class. Next thing we want to talk about is the geometric mean. I know most of you think geometric mean is what Miss Fabris gets when you don't do your homework. But what it actually is when you multiply two numbers together and take the square root of the product. So if we have the ratio of 15 over x equals x over 11, x times x is x squared, and x squared is equal to 15 times 11. So what we'd actually do is just take the square root of 15 times 11, and we're going to give you an example right here, and then you'll do a couple on your own. So if we look at number 14, the geometric mean of 4 and 8, x is going to be the square root of 4 times 8. 4 times 8 is 32. So x is the square root of 32. You're going to reduce that radical, and you'll end up with x equals 4 square roots of 2. You will go over reducing radicals in class. You're going to be doing it a lot over this unit. Number 15, again, if we go with the geometric mean of 12 and 9, it's going to equal the square root of 12 times 9. 12 times 9 is 108. So we're going to take the square root of 108. 108 is 36 times 3. Square root of 36 is 6. So we end up getting 6 square roots of 3. So go ahead and try to do 16 and 17 on your own. And again, we will check those in class. Finally, there are some additional properties of proportions, which are up here. If a over b equals c over d, then you can flip them over and you still have a true proportion. So a over b will equal b over a will equal d over c. You can also switch these terms. So if a over b equals c over d, then a over c is going to equal b over d. That's also true. And then this one, so those two kind of make sense. This one's a little strange, but you just have to remember it. So if a over b equals c over d, then we can add the denominator of both to the numerator, and a plus b over b is going to equal c plus d over d. That will also be a true proportion. So using those proportions, if we were to tell you that mn over rs equals np over st, and we're looking at these diagrams, and we want to write 4 true proportions, proportion number 1, you just substitute in what you have. So we can see mn is 8, rs is 10, np is 4, and st is x. So 8 over 10 is going to equal 4 over x. Okay? Now, as I said, we could flip these over and still have a valid proportion. So I could say that 10 over 8 equals x over 4. And all I did here was flip these over. Right? Going back to the original again, if we look at the other thing we said we could do is we said we could swap these numbers. So 8 over 4 is going to equal 10 over x. That's also a true proportion. And then finally, adding the denominator to the numerator would give us, as we saw, our denominator here was 10, our numerator was 8. So add those together, you get 18 over 10 equals 4 plus x over x, because 4 plus x is, the numerator plus the denominator. So that's 4 true proportions we can write based on these two triangles. In the next diagram, BD over DA is equal to BE over EC. This, a lot of students get confused. So we're just going to plug in what we have here into this and find the length of BA and BD. All right, so BD is this piece. This whole thing is X. So if this whole thing is X and this much is 3, then BD is going to be X minus 3. So that's where this X minus 3 comes. BD over DA, which is 3, is going to equal BE, which is 18, over EC, which is 6. We're going to go ahead and cross multiply just the way we would solve any other proportion. So 6 times X minus 3 is going to equal 3 times 18. Don't forget to distribute, which will give you 6x minus 18 equals 54. We add 18 to both sides, 6x is 72, and divide by 6, we get x equals 12. But again, I don't want x, I want the length of BA and length of BD. Well, we know that BA is x, so x is in fact 12, so BA is 12. And BD, as we said over here, is x minus 3, so 12 minus 3 is 9, which is the length of BD. A couple other definitions and a couple more problems. First, a scale drawing. A scale drawing is a drawing or a model, could be called a scale model, that shows real objects with accurate sizes reduced or enlarged by a certain amount. And we call that amount the scale, which ironically is our next definition. The scale is a ratio of the length in a drawing or model with the matching length in the real thing. So the example we have here, number 3, by a 3D scale model of the Reunion Tower in Dallas, Texas. The actual building is 560 feet tall. Your model is 10 inches tall. The diameter of the dome on your scale is about 1.2 inches. What is the diameter of the actual dome? So all we're going to do here is set up proportions to solve this. We're going to use the model size over the real size to set up our proportion. We know that the model size height is 10 inches and the actual building is 560 feet. The model size diameter of the dome is 2.1 inches. We want to find out the diameter of the actual dome in feet. So there's an x. And then to solve this, we'll just cross multiply. 10 times x is 10x equals 560 times 2.1. So 560 times 2.1 is 1,176. And if we divide by 10, x is 117.6 feet. So that would be the diameter of the actual dome of the Reunion Tower in Dallas. The next question is a little more complicated. It asks about how many times as tall as your model is the actual building. I typed up an explanation here. We go. Since we know the model is 10 inches tall and the actual building is 560 feet tall, we could say that the ratio or the scale would be 1 inch on the model is 56 feet on the actual building, because we put 10 over 560 and reduce it. 56 feet translates to 672 inches if you multiply 56 by 12. So the building, because 1 inch is 672 inches, the building is actually 672 times as tall as your model. Hopefully you were able to follow along with the notes. If you have any questions, we have Tuesday morning help sessions from 8 to 8:45. Please come in and join us. Thanks and have a great day.